Hello everyone, welcome back to another tutorial of Signals and Systems with MATLAB. In this tutorial, we are going to start from the very basics of the signals and systems. So first of all, let us discuss how we can plot multiple types of signals in MATLAB. So basically, when we talk about the types of signals and systems, we have mainly two types of signals. One is the continuous time signals and second is the discrete time signals. So let's start with the plotting of continuous time signals. To work with the signal and systems with MATLAB, we have to perform three basic steps. First one is CLC, which means clear screen. The CLC command clears the command window. As you can see that we have outputs, previous outputs in the command window as I have been working with MATLAB. So when I run this command, it will clear command window. So as you can see that I have pressed the run button and it has cleared command window screen. So the next step is clear all. What clear all commands does, it clears the workspace. Basically in workspace, our previous variables are stored. So as you can see that currently my workspace has some few stored variables. So when I run this command, what it will do, it will clear my workspace and it has successfully cleared my workspace. So the next command is close all. Basically, close all command is used to close all the existingly opened windows of MATLAB. I have been working on the MATLAB and I have few open windows of MATLAB with me. Basically, those were few graphs. So when I run close all command, and what it will do, it will close all of my previous commands of the previously opened figures of the or any tabs of the MATLAB. So now let's start with the continuous time signals. So I am going to write about I have added a comment regarding continuous time signals in MATLAB. So basically in continuous time signals, our time and amplitude both are continuous. So if we draw our continuous time signal, so time will be on the x-axis and the amplitude of the signal will be on the y-axis. So let me initialize time. So let's suppose that I want to give it a time from minus 10 to 10. So this will be the value of time. Basically it has 21 elements in it and it has the step size of 1 by default. So if I write here 2, it will give me a jump of 2. So I have not included semicolon here. Semicolon is used to hide the output of this very specific line. So let me run this and we will see its effect in the command window. So I have ran it and you can see that it is giving the jump of 2, minus 10, minus 8, minus 6, minus 4, minus 2 and up to so on. So let me take another example. If I write the step size of 5, it will give me only 4 values, minus 5, minus 10, 0 and 5 and 10. 5 values basically. So here it has gave us minus 10, minus 5, 0, 5 and 10. So while dealing with the signals, it is preferred to have the step size of 1. So here we can see that it has generated a vector matrix of a row vector matrix of 1 cross 21. It has 21 elements. So to avoid confusion in command window, I am going to place an semicolon here. It will suppress the output of this very specific line in the command window. So now let me define my signal. In signal, basically I am going to plot a continuous time unit step signal. So what is unit step signal? Unit step signal is has the amplitude of 1 from 0 to up to positive infinity, and on its negative side it has the 0 amplitude. So since we are working with the MATLAB, then there we cannot plot empty because infinity is sorry, we cannot plot infinity because infinity is the unlimited value. So since my time has total element 21 elements, so to plot anything in MATLAB, because MATLAB is a matrix laboratory, so the matrix length should be same. So I have to initiate 21 samples here as well. So I will select 11 samples of zeros and 10 samples of ones. What it will do, it will place an amplitude of 1 at the when time is equal to 0. So let's do it. Zeros 1 colon 11. So what it will do, it will generate a row vector of zeros. and which has 11 zeros. So my signal will cover the first 11 points as 0 and ones 1 comma 10. So when these both of these are together in a single row vector, so it will give me a different output. So let me run it and I will show you what it actually means. So in the command window we can see that, sorry, it has a error, project line 8 error in so it is saying that incorrect argument data type or missing statement in the call function zeros. Basically it's not zero, it's zeros. So I have corrected my mistake. So now let's rerun it. So once I rerun it, you can see that it has totally 21 elements. But the first 10 elements are 0 and the first 11 elements are 0, but the coming 10 elements are 1. So when I will plot this, it will give me a perfect continuous time unit step signal. So let me plot it. To draw a continuous type graph in MATLAB, a command used is called plot. So x-axis, then our y-axis, and now I want to give it a title. So I will write the command title and continuous time unit step signal. Okay, fine. And in the next I want to name its x-axis, so the command is used x label. So x label, we have time in seconds, and in the y label is for the labeling of y-axis. I will write signal values. So let me run it. So once I have pressed the button run, you can see that it has shown me a figure uh, which whose title is a continuous type unit step signal, times in seconds, signal in values. You can see that it has a value of 1 at the sample 0. Since it's a continuous time graph, so that's why there is a tilt little bit slope in this graph. So now we have successfully drawn our continuous time unit step signal. So now work on the discrete time signal. So in the discrete time signal we have no time, we have number of samples. So on the x-axis we plot number of samples, and on the y-axis there is the value of the signal. So let me initialize, let me write a command since I want to open both of these figures. So the command figure is used for this purpose. It will open a new tab with the figures and it will not replace my existing figure. And if I do not write this figure at the end of this course, when I will run this command, it will replace my previous figure. So with the figure command, let me initialize the samples. So to make both of these codes similar, I will choose same sample size. So the samples will be from -10 to 10. Okay, you can see that I have not write here 1. So by default it takes the step size of 1. So let me initialize another variable, d underscore signal. So it is recommended to not to overlap these signals. If you name both signals with the same, so it will replace the previous one. Since I am dealing with the same number of elements here, you can simply use the previous this signal, and you can map it on our new number of samples. But for your better understanding, I am rewriting this signal. So let me initialize a row vector. This row vector will be based on the zeros, 1 colon 11 space ones 1 comma 10 brackets close, and this row vector is complete. So I have put the semicolon in front of this because I do not want to uh, see the output in the command window because it is irrelevant. So in the workspace you can see that our previous signal and times have both of these variables have been stored. These are the variables and these have this value of this row vector. So now I want to see the graph of this discrete time signals, and in MATLAB we used the command stem to observe the discrete time signals. So on the x-axis it will have samples, and on the y-axis it will have d underscore signal. So brackets closed, and now I want to label it. So to save my time, I have simply copied the above command. So the title is discrete time unit step signal. Time in samples, I will replace in it as number of samples. So number of samples is here. So let me run this code. Before running this code, I want to recall you, we will have two windows for the figures open, and one will show us continuous time signal and other one will show us discrete time signal. So let's run it. So we can see that it has opened two windows. So now let me open the side to side. It has opened two windows. The first figure one is called continuous time unit step signal and the second one is discrete time signal. So now we have successfully uh, uh, practiced this task in the MATLAB. Here you can see that it has number of samples here and the signal values, it has time in seconds and the signal values. So this was the very simple task to perform in the MATLAB. Hopefully you would have liked this, and if you want to make me more videos like this, you can request those in comment section. Thank you so much.